Hello, 8th graders. Your new video is section 9.5, and that is on exploring similar sides. Or similar solids, excuse me. So similar solids, that's just two solid shapes that are the same shape and have proportional corresponding dimensions. So it's just like when we talked about similar shapes before. Remember when you had similar triangles, they were the same type of triangle, the same shape of triangle. One was just bigger than the other. But remember that the sides have to be proportional. So if one is 3 times as big, like every side has to be 3 times as big. So my example here, 2 cylinders are similar. The small cylinder has a diameter of 4 meters and a height of h. The large cylinder has a diameter of 5 and a height of 11. What is the value of h? We've done stuff like this before, last year and this year. You just have to set up a proportion, right, to be able to do this. So 4 So I have 4 for my diameter, h for my height on the small one. And I need to make sure that since I have diameter on the top here, I need to have diameter of the big one on top here. So 5 over 11 for the height. And I'm just going to crisscross and solve my proportion. 4 times 11 is 44. 5 times h is 5h. And then I'm going to divide by 5. And I'm going to get 8.8 meters for my height. There's not much to that. We've done this before when we did the scale models and the scale drawings, all that stuff that we did. You have to set up proportions. It's all for what you don't know. So then, for this next part, it says if the ratio of corresponding dimensions of similar solids is a to b, then the ratio of surface areas would be a squared over b squared, a squared to b squared, right? Surface areas are squared. They're just saying the area of the first one compares to the second one, right? Squared. The ratio of volumes would be the volume of A to the volume of B. Like they all have to equal. When you reduce them all, they have to be proportional. So here I have a box, has a surface area of about 54 square inches and a volume of 27 cubic inches. The edge lengths of the box are 1/3 of the edge lengths of the larger box. Find the surface area and volume of the larger box. So we know the smaller one. We need to know the bigger one. Okay, so let's do surface area first. So surface area is 54. And we know that our bigger one has to be 3 times bigger, right? You're not going to use 1/3 because you don't want to get smaller. You want to get bigger. And since it is surface area that we're talking about, you're going to square the surface area. So you'll take 54 times 9. Because everything has to be proportional, right? 486 square inches. The reason we square this is because every dimension has to be proportional. It can't just be one dimension that's proportional. You can't just take it times 3. Every dimension, and since a box has two dimensions, right, when you're doing surface area, like length and width, or base and height, that's why you have to square it. So then we also need to do volume, and volume is 27 for the smaller box. So we're going to take 27. Again, our scale factor is going to be 3, but in the case of volume, volume is 3-dimensional, so you're going to cube the 3. So 3 times 3 times 3 is 27. So you will take 27 times 27. So 729 cubic inches for the volume and 486 square inches for the surface area. So again, how did I do that? I took the surface area they gave me, and because it's the smaller box that they gave me and I want to get bigger, I have to take it times my scale factor of 3, and I have to square it because it's surface area. Volume, I had to cube the scale factor of 3 because it's volume. Volume is three-dimensional. How would this have changed if I would have had if I had the bigger box and I wanted the smaller box? The only thing that would have changed is this. You would have used the 1/3 because you do want to get smaller, right? So you would have taken 54. Well, you would have had to square this first, right? For some reason my pen isn't working. You'd have had to take 1/3 times 1/3, which would be 1/9, right? So really you would just take 54 divided by 9, and you would have got 6 for the smaller one. You have to be careful with if you're starting with the smaller shape or the bigger shape, because that's going to change what your scale factor is. So bring this knowledge with you, and we will talk about it more tomorrow. Have a good night.